Hey there, hope you're having a wonderful day. In this video, we're going to be coding a calculator in Java. So here you can see we have the calculator and I can put in some numbers. So I can do 24.75 times 54.32 equal. And you can see we get our result, and I can do negative, positive, and I can take the percentage of this number. So dividing it by 100, and I can also subtract 10. And yeah, so you can see we have a functional calculator, and I can also clear everything. So this is what we'll be building in this tutorial. And before we begin, I just want to quickly mention that I am working on various tutorials on my YouTube channel. So here you can see I have programming basics in Python and C++, and you can also jump to a tutorial section. So you can jump to Java games. So I have various tutorials in Java for building game projects, such as Pac-Man, Match Cards, Space Invaders, Flappy Bird, Blackjack, Minesweeper, Snake, and I have other tutorials in JavaScript and Python. And yeah, you'll find all of these tutorials on my YouTube channel, as well as on kennyupcoding.com. If you want to stay up to date for more tutorials like this one, make sure you subscribe to the channel. Alright, so let's begin. So for this tutorial, I will be using Visual Studio Code with Java. And I highly recommend you do the same if you want to learn how to set up Java in Visual Studio Code. I have a tutorial on that on my channel, and I'll link the video in the description below. Alright, so let's begin by creating a Java project. So press Ctrl-Shift-P and Java, create Java project, no build tools. And I'm going to select my desktop as the project location. And for the project name, I'm going to call it calculator. Alright, so we have our project, and if I click on the source folder, you can see we have the app.java file. So this is going to be our main file, and I can click the run button, and you can see we get hello world. So the first thing I'm going to do is right click on the source folder, new Java file, and I'm going to create a new class and call it calculator. And then here, I'm going to remove this print statement, and I'm going to create an instance of the calculator. So calculator is equal to new calculator. And that's all we need for this file. So I'm going to close this and collapse this. So we have our calculator class, and the first thing I need to do is import a few things. So I'm going to import java.awt.*, import java.awt.event.*. So this is going to be for our graphics library and event handling. And then I'm going to import java.util.arrays. So we're going to be working with arrays for listing out the buttons. And then I'm going to do import javax.swing.*, and import javax.swing.border.line_border. So this is going to be for modifying the border of the buttons on our calculator. Alright, so the first thing we need to do is create a window for our calculator, and that is going to be our JFrame. So I'm going to do int board width is equal to 360, and when I say board width, I'm referring to the window. So in all of my tutorials, I tend to call the window board. So int board height, I'm going to make this 540 pixels. And then let's create our window. So the window is a JFrame, and I'm going to call it frame is equal to new JFrame. And in the constructor, I can pass in a title. So this is going to be the text you see at the top of the window. So I'm going to call this calculator. Now let's create the constructor. So calculator. And in here, I'm just going to modify the window. So first, I'm going to do frame.setVisible. I'll set it to true so that we can see the window. Frame.setSize is going to be board width and board height. And then I'm going to do frame.setLocation relative to, and I'm going to make it null. So this is going to center the window. Frame.setResizable, make it false so that the user cannot drag on the sides of the window to change the width and height of the window. And then frame.setDefaultClose operation. This is going to be jFrame.exitOnClose. So when the user clicks on the X button of the window, the program will be terminated. And I'll do frame.setLayout new border layout. So with the border layout, I can place components north, south, east, or west within the window. All right, now let's save and run the program. And you might end up with this issue, basically main method not found in this class calculator. And that is because when you run a Java program, it expects there to be a main function. So our main function is in our app.java file. So to resolve this, just click on this dropdown and click Run Java. And there you go. So you can see we have our window. And after you click the Run Java once, you can just click on this Run button. So we have our window now, and the width is 360 pixels and the height is 540 pixels. Now let's add some components within our window. So we need two panels. One panel is going to be for displaying the numbers, and the second panel will be for holding all the buttons. So let's start with the panel for the display. And before we add those components, I just want to define some colors that we'll be using. So for our calculator, I'm going to be using the same colors that you would find in an iPhone calculator. So I just looked up the colors for the iPhone calculator, and you can see it uses light gray, this black color, this dark gray, and this orange. And we have the RGB values. So I'm just going to copy each one. So I'm going to create some custom colors. So color, and I'm just going to call this custom light gray is equal to new color. And we need to specify the RGB value. So it's going to be 212, 212, and 210. Let's create three more colors. So color custom dark gray is equal to new color 80, 80, 80. And then color custom black is equal to new color 28, 28, 28. And finally, custom orange is equal to new color 255, 149, and 0. Alright, so we have our colors. Now let's start with our J panel for the display. So within our panel, we're going to add a label for the text. So I'm going to create a J label, and I'll call it display label, new J label. And then I'll create a J panel, display panel is equal to new J panel. So we're going to put the text inside the label, and then place the label inside the panel, and then place the panel inside our window, which is the J-frame. So in our constructor, let's add some styling for the label and panel. So I'm going to do display label dot set background, and I'm going to make the background a custom black color that we defined earlier, and display label dot set foreground. So this is the text color. I'm going to make the text color dot white. Next, we'll do display label dot set font new font, and we'll do Arial font dot plain, and we'll make the font size 80 pixels. And we want to display the text to the right, just like how a calculator would display the numbers to the right. So I'm going to do display label dot set horizontal alignment, and I'm going to make this J label dot right. Now let's add a default text. So I'm going to do display label dot set text 0. And let's also do display label dot set opaque, and I'll set it to true. Alright, so we have the label. Now let's work on the panel. So display panel, and I'm going to set the layout to be new border layout, and display panel dot add display label. So we're putting the text label inside the panel, and then we need to do frame dot add display panel. So we put the label in the panel, and then the panel in our window, which is the frame. Alright, now let's save and run the program. And you can see we have our display panel over here, and we have the display label, which has the number 0, and it's floating to the right side. And the font is white, and the background is our custom black color. Now I don't want this panel to take up the entire space. I just want it shifted to the very top over here. So when I'm adding the display panel to the frame, I'm going to add another parameter, border layout dot north. Alright, now if I save and run the program, you can see we've placed the display panel on the northern part of our window. So it's stuck here on the top. And now we can add another panel on the bottom for our buttons. So just like with our display text, I'm going to create another panel for our buttons. And I'm going to call this buttons panel is equal to new J panel. Alright, so we need to list out all the button values. I'm going to have those prepared, so give me a moment. And I'm going to paste it over here. Here you can see we have 3 arrays, and the first one is for our button values, and we have the rightSymbols and the topSymbols. So I'm going to add this in the video description so that you don't have to write everything out. So basically, we have the button values, which is one of the arrays, and this lists out all the values that we have for the buttons. And then we have the rightSymbols. So this is going to be for the operators and the equal symbol. And then we have the topSymbols, which is clearing, plus, minus, so positive, negative, and percentage. So when we create the buttons, we're just going to iterate through this array, go through each symbol, and create a button. Whereas for these rightSymbols and topSymbols, we're going to be using these to distinguish which buttons get the orange color and which ones get the gray color. And we're also going to use them to process the button clicks to determine which type of button is being pressed, whether it's an operator or these other buttons. And the ones that are not listed would be the numbers. So from 0 to 9 and the decimal. And there's also this square root. And in this tutorial, I'm not going to implement the square root operator. So I'm going to save that for you to complete. In this tutorial, we're going to cover every single button except this square root button. And another thing, you might notice that there's a box around this multiplication symbol, and that is because it is the multiplication symbol. It's not an X, so you can see it's different from the multiplication symbol. So yeah, just go to the video description and copy these 3 arrays. Alright, so let's create the buttons, and we have 5 rows of buttons, and in each row there are 4 buttons. And I deliberately organize this array like so it's easier to visualize. So let's go to the constructor, and over here I'm going to do buttons panel dot set layout, and I'm going to create a grid layout. So new grid layout, and we're going to have 5 rows and 4 columns. And then I'm going to do buttons panel dot set background, and let's make it the custom black color. And then frame.add buttons panel. Alright, now if I save and run the program, you can see we have the top part, which is the display panel, and this bottom part, which is the buttons panel. And the background is the custom black color, just like with the display panel. So let's add some buttons. So as I mentioned earlier, we're going to iterate through every symbol. So for int I is equal to 0, I is less than button values dot length I plus plus. So I'm going to create a button. So J button. Button is equal to new J button. And then string button value is equal to button values at index of I. And then let's add some properties for the button. So button.set font, new font, Arial, font.plain, and I'll set the font size to be 30. And then button.set text, we're going to put the button value as a text. And then I'm going to add this button to the buttons panel. So buttons panel dot add button. Alright, now let's save and run the program. And you can see we have all of our buttons here. We have 5 rows and 4 columns. And if I click on each one, nothing happens. If you notice, if I click on each button, there's a rectangle around the text. So let's get rid of that. So to get rid of that, I'm going to do button.setFocusable, and I'll make it false. Alright, now if I save and run the program, and if I click on each button, you can see there's no rectangular box around the numbers. Okay, so let's style up the buttons. So there are 3 categories of buttons. So if arrays.asList topSymbols.contains button value. So if this current symbol is part of the topSymbols array, then I'm going to set the background to custom light gray. And the foreground, which is the font color, this will be custom black. Else, if arrays dot as list right symbols dot contains button value. So if this is an operator symbol, so all the buttons on the right, then we want to make the background custom orange. And then button dot set foreground will make the text color dot white. Else, if it's none of these, that means we have a digit, so 0 to 9, or the decimal place symbol. I'll do button dot set background custom dark gray, and button dot set foreground color dot white. Now if I save and run the program, you can see we have the top symbols over here. They have a light gray background and a black font color. And on the right symbols, we have an orange background and white font color. And the remaining buttons, which are the digits and this decimal place button, as well as this square root button actually, we're going to make them a dark gray color and the font is going to be white. Now there's one more thing I want to add, and that is the border color is still the default blue color. So I'm going to change the border color to match this black color. So over here, I'm going to do button dot set border, new line border, and the color is going to be custom black. So now if I save and run the program, you can see the border is now that custom black color. So we have the UI completed, and now we want to make the buttons do something when we click on them. So down here, I'm going to do button dot add action listener, new action listener. In the action listener, we need to define public void action performed action event E. So in this case, the action performed will be a mouse click, and E refers to the action. We need to get the button that was clicked on. So I'll do JButton. Button is equal to cast of JButton E.get source. So E is the action event and source is where that event comes from. So the event is going to be a click, so the source of that click is a JButton. And after we get the button, we need to identify which button was clicked on. And to identify the button that was clicked on, we need to get the symbol or the text that is displayed on the button. So this could be the operators for addition or subtraction, or it could be a number. So I'm going to do string button value is equal to button.getText. Alright, so in our calculator, we have three groups of buttons. We have the top symbols, the right symbols, and the digits. So the top symbols would be for clearing, percentage, or positive negative. The right symbols would be for the operators and equal. And we have everything else, which is the digits and the decimal symbol. So let's break this down into three if-else statements. So if arrays dot as list right symbols, so these are the operators, dot contains button value. Else if arrays dot as list top symbols dot contains button value. And then we have else. So this else statement would be for the digits or the decimal place symbol. So we're going to check the button value, and based on which group, we're going to process the button value. So in this case, I want to start from easiest to most difficult. And the easiest is just pressing the numbers or the decimal place, because when you press on a number, you're just adding another digit to the display. So within this else statement, I'm going to make a check because we have two groups that we want to check for. So if button value is equal to the decimal place, and then the other one will be else if, here I'm going to make a string of all the digits, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot contains button value. So let's start with the digits because this is the easier one to do. So if we have a digit, I want to check one more thing, and that is if display label dot get text is equal to 0. So if we have a 0, I don't want to add a number right after. So if I have 0 and I press 5, I don't want 05, I just want 5. So if the current display label text is a 0, we're just going to replace it with the digit. So display label dot set text button value. Okay, so instead of doing 05, we just get 5. And then else, if it is not a 0, that means we can add some digits to the end. So I'm going to do display label dot set text display label dot get text plus button value. So let's save and run the program. And it seems we have a semicolon missing somewhere on line 99. So where's that? Over here. So that is the function add action listener. So we need to add a semicolon over here at the end of that function. All right, so make sure you have this semicolon over here. Now let's save and run the program. And you can see we have a 0 over here. And if I press any number key, it's going to replace that 0. So if I press 5, you can see we have 5, and I can press other numbers. Okay, so the digits are working. Now let's add the click handler for the decimal place. Okay, so if the button value is a decimal place, I'll add the decimal place right after the current text. But before I do so, I want to make a check. And that is because I don't want to add the decimal place multiple times. You either have the decimal place once or you don't have it. So I'm going to do if not display label dot get text dot contains button value. So if our current display label doesn't have a decimal place, then I can add one. So I'll do the same thing I did over here and just add the decimal place right after the current text. So I can just copy and paste this and pop it over here. All right, now if I save and run the program, you can see I can do 5.24. And if I try to add another decimal place, nothing happens. Okay? All right, so we have all of these values done except the square root. I'll leave that to you. Now let's work on the top symbols. So we have clearing, positive, negative, and percentage. So if button value is equal to AC, so this is for clearing, else if button value is equal to plus slash minus, so positive or negative, else if button value is equal to percentage. So let's start with the first one, which is clearing. And what are we clearing here? So when we click clear on the calculator, we want to clear all the existing numbers that we entered. So we need to save those numbers. So if I scroll all the way up here, I'm going to create 3 variables. So string A, and I'll set this to 0. String operator, and I'll set this to null. And string B, and I'll also set this to null. So these 3 variables are going to keep track of the 2 numbers and the operator. So for instance, we would have A plus B, or A minus B, or A times B, or A divided by B. So that's what A and B represent, the 2 numbers that we're working with here. And we have the operator, which is the plus, minus, multiply, or divide. So when we click on a digit and then the operator, we would save the first number to A and the operator to this variable. So when we click clear, we want to clear everything. So we would reset everything back to this default state. So if we click on the clear button, I'm going to call a function called clear all. So let's define that function down here. So void clear all. And this is just going to set the A back to 0. Operator is going to be null. And B is going to be null. So after we set all the variables back, I want to update the display. And I'll set the text back to 0. Okay, now let's save and run the program. So if I do 1526 and I press clear, you can see it sets everything back to 0. And normally, if I do 1, 5, 6, for example, if I click on any of these operators, we would reset the text back to 0, and this 156 would be stored in the variable a. So we'll implement that in a bit. Let's just focus on these other two. So positive, negative, and percentage. Okay, so for positive and negative, what we're going to do is get the number value and then multiply it by -1. So it toggles back and forth. So we're just multiplying it by -1 to make it negative, and then we multiply it by -1 again to make it positive again. So here I'm going to do double num display double dot parse double of display label dot get text. So we're going to get the text and convert it to a double. And then we just do num display times equal -1. And then afterwards, we need to update the display again. So I'll do display label dot set text double dot toString num display. All right, now let's save and run the program. So if I do 5, 8, 4, and I press on this button, it's going to make it negative. And then I press it again, it makes it positive. Okay, so it goes back and forth. And one thing you might notice here is we have 584, so 584, this is a whole number. So we don't need this 0.0 over here. And the reason why we have a 0.0 is because we convert it to a double and then convert the double to a string. So with a double, we have floating point numbers. So what we can do is make a check to see if it is a whole number, and if so, we can just convert it to an int. So instead of directly converting the double to a string, I'm going to call another function that would make the check to see if it's a whole number. And I'll call that function remove 0 decimal. So let's define that down here. So I'm going to return a string remove 0 decimal, and it'll take in a double num display. So if num display mod 1 is equal to 0, this means we have a whole number. So if you have a whole number mod 1, there's nothing remaining. There's no decimal place. So I'll do return integer dot toString, and I need to cast the double to an int, so I'm going to do int cast of num display. Else, if it's not a whole number, I'll just do return double dot toString num display. Okay, so I'm going to call this remove 0 decimal function. So let's save and run the program. And if I do 584 and make it negative, positive, you can see there's no 0.0 here unless I add 1 myself. So if I do 0.0 and I make it negative, you can see it removes that 0.0. Okay, and I can do 0.25. And in this case, this is not a whole number, so it's going to keep the decimal places. All right, and finally, let's work on the percentage button. So this is just dividing by 100. So percentage is actually very simple. I can just take what I did here and paste it over here. So what are we doing? We're getting the number from the text and converting it to a double, and we multiply by -1. Instead of doing that, I can just divide it by 100. And then after I divide it by 100, I just set the number back on the display label. So this one's very simple. So if I save and run the program, I can do 100 and click on the percentage. You can see we get 1. And if I do 12500 and click the percentage, you can see we get 125. And if I click it again, we get 1.25. Alright, so that's all for the top buttons. Now let's finally work on the buttons on the right. So we have the operators and we have the equal symbol. So here I'm going to do if button value is equal to the equal symbol, else if, and here I'll list all the operators. So we have plus, minus, and I need to copy the other two symbols. So one of them is this multiplication symbol. So I'm going to copy and paste that. And then we need the division symbol. So I scroll back up. I want this symbol over here. So if it's one of these four symbols, so dot contains button value, we have the operator. So I'm going to start with the operator because this is the easier one to do. So if operator is equal to null, So this means that we just pressed a number and we click the operator for the first time. If it's equal to null, then I'll save this number to A. So A is equal to display label dot get text, and I'll set display label dot set text to 0. So this is going to prepare for the second number, B. So I'll do B is equal to 0. And then outside, I'll do operator is equal to button value. And the reason I'm doing it this way is because if I don't check for null, then the user can click on the operator twice. So if they do addition and then subtraction, then we're going to set A again and reset the text. We only want to do this once. So if the user clicks on addition and then subtraction, we're just going to change the operator from addition to subtraction. Okay? So if the operator is null, we will save the A value and the operator. And if it's not null, that means we're just changing the operator. So let's save and run the program so I can show you what I mean. And you can see my buttons are messed up here, and that is because when I'm recording, my computer is slower and it doesn't render everything correctly. So to get around that, if you experience that issue, what you should do is take the frame.setVisible over here and just comment this one out. And usually you want to set the frame visible after you've added all your components. So after adding the label and panel and the buttons, so I'm going to go all the way down over here and set frame visible to true. So that should fix everything. So if I save and run the program, I shouldn't run into that issue where the buttons are all wonky. Alright, so as I was saying, if I click on a number, so 150, and I click on any of these operators, the first time I click on the operator, the variable operator is set to null. So if I click multiply, you can see we save the operator as multiply and we save 150 as A. Now if I click on any other symbol, again, such as subtraction, well, the operator is not null because we have multiply. So it's just going to replace multiply with subtraction. Therefore, A will still be 150 instead of 0 over here. So that's why I made that check earlier. So now if I add a second number, let's say 95, and I click on any of these operators, nothing happens. We're just switching. So it'll be 150 divided by 95 or 150 multiplied by 95. So if I click on the operator again, I'm just updating the operator. And it's not going to affect A, which has 150. So the 95 is still here, and we only set this to B when we click this equal symbol. So let's define this. So over here, I'm going to do if A is not equal to null. So if we already have a value for A, then I can set the current display text to B. So I'll do B is equal to display label dot get text. And now we have A and B. So we have A from here when we press the operator, and we have B when we press the equal. And now let's get the numeric values. So double num A is going to be double dot parse double of A. And let's do the same with B. So double num B is equal to double dot parse double of B. Okay, so we have A and B converted to numbers. Now we just need to figure out which operator we clicked on. So if operator is equal to plus, I'm going to do display label dot set text, and we'll do remove 0 decimal of num A plus num B. So we're going to add num A and B together, and then we're going to get the string value. And if it's a whole number, we just remove the decimal place. And I'm just going to copy and paste this. So else, if the operator is minus, then we're going to do num A minus num B. And let's copy and paste this. And here I'm going to copy this multiplication symbol. Remember, it's not an X, it's the multiplication symbol. So if we have multiply, I'll do num A times num B. And finally, we have division. So I'm going to copy and paste this division symbol. And I'll do num A divided by num B. And after we've applied the operation, I want to clear all. So clear all is going to reset A, operator, and B back to the default values. Alright, so let's save and run the program. So I'll do 100 times 5 is equal to 500, and I can divide it by 10, we get 50. I can subtract 64, we get negative 14. I can make this positive again by clicking on this positive negative button, and I can add 25, maybe add a decimal place, so 0.19 plus 5.81, and you can see we get 45. Okay, and we can clear, and I can do 250 minus 68, and I can add some more digits. So I can do 1825 times 2 divided by 50, and you can see we have a fully functional calculator here. So if I divide by 100 by clicking on the percentage, or times 1000, or 10,000 actually, so let's press equal and then clear. Okay, so we have a fully functional calculator. If you want to continue working on this project, you can implement the square root operator, which is just to the power of 0.5, and you can add some additional buttons, make the calculator bigger. So some buttons you might want to add are the power function, or maybe absolute value, or maybe you can add a button to delete digits. So here you can see I can do 5, 6, 8, and maybe I press 9 by accident. Maybe you can add a button to delete this last digit that was added. You can also add some scientific buttons such as cosine, sine, or logarithmic. So this is all up to you. I definitely encourage you to continue working on this calculator project and add more features and functionalities. But yeah, so that's it for this tutorial. If you found this tutorial helpful, make sure you give this video a like. If you have any questions, let me know down below in the comments. And as always, if you want to stay up to date for more tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.